All right, in this video we are going to talk about the amplitude of a sinusoidal function. Okay, so what the amplitude of a sinusoidal function is, it's the maximum distance between any point on the graph and the midline. All right, so the distance between the point that's the midline and any point on the graph that's farthest away from the midline. And it is, again, pretty easy to find if you have the formula, right? Remember our formulas that we're using are y equals a sine bx minus c plus d, or y equals a cosine bx minus c plus d. And the amplitude is going to be the absolute value of whatever the a parameter is. So that number that's being multiplied on the outside of the sine and cosine function. Okay, and so the amplitude, what it is, it's a vertical stretch or shrink. So here, with the regular sine function, it would be 1, right? And so you can see if I'm increasing the value of the parameter a, right, as if it were 5 or 6, right, the distance between the midline, which in this case is y equals 0, and the peaks, right, the maximum values or the minimum values, however you want to say that, is getting farther. If that number is in between 0 and 1, right, it's going to be a vertical shrink, right? Those things are going to shrink and get lower, smaller, right? So the maximum value, the distance between these maximum value points and the minimum value points between those points in the midline is getting smaller. All right. One important thing to notice is that, all right, we're talking about sine right here, and for a pot sine, remember the basic sine function has a amplitude of 1, right? And because the number in front of the sine is a positive 1, and remember that the sine starts at 0, 0 here and it goes up, right, like this. If the number a is negative, let's say, then that reverses, right? So if we're talking about the sine function and the number out in front is a negative, because it's negative, it reflects the graph of the regular sine function about the x-axis, right? And so now the sine, if the number out in front is negative, if the a value of a is negative, it will start at 0, 0 and then go down, okay, like so. So that's an important fact to know. And the same will be true, right? If it's been vertically shifted up, then the same thing will be true with respect to the midline. Okay, so it will start at 0, right? If there's no horizontal shift, and then it will go down if the value of a is negative. Okay, that's assuming there's no horizontal shift, which we haven't talked about yet. And for cosine, remember the normal cosine function has a equals 1 and d equals 0. So the normal cosine function looks like this. If the number out in front, so it will start up at one of the maximum values at 0 and then go down, like so. If the value of a is negative, right, it'll be the opposite of that, right? What it will do is start at the bottom at 0 and then go up, like so, for cosine. Again, that's assuming that there's no horizontal shift, okay? So that's something, again, to keep in mind when you're working through some of the Newton problems. Whether, you know, it goes down or up, right? So for remember, the usual sine function starts at 0, 0 and goes up, right? The usual cosine function starts at the maximum value and goes down. And so if the value of the a out in front, assuming that there's no horizontal shift, which makes things more complicated, it will be the opposite of those values, okay? All right. So again, if you have a vertical shift, like in this case, if we have d equals 2, remember the midline would be 2. put this back to 1. Then the amplitude, right, gives the distance between the midline, right, and the highest and lowest points, right? So this point is up at 4, right? The distance to the midline would be 2 here, and then the distance from any of these minimum points to the midline would be 2 as well, and you can see the amplitude is 2 here. All right, so that's what the amplitude is. It's the distance between a maximum and minimum and the midline, and that would be the absolute value of A. Okay. All right, let's take a look at a couple of examples for finding that. It's really easy if you have the graph. All right, so let's do this one first. So the amplitude on this one, right, y equals -4 sine pi x minus 2 minus 3, the amplitude would be the absolute value of -4, right, which is +4. Okay, so that's the amplitude. And you can see that pretty easily if you have the formula, right, in the standard form. It's pretty easy to spot that. Now, let's say you didn't have the formula and you wanted to find the amplitude. What if they just gave you the graph? So what you would do is, again, find the midline. So the midline, remember, you can find by taking the average of the maximum and minimum values. So that would be -1 plus 7 divided by 2, which is, oops, did that backwards. It's 1 and -7. So the midline is y equals -3, like so. And then what you would do is find the distance, right, from this line, y equals -3, up to a high point or low point. So in this case, what's the distance between 1 and -3? And you can get that by subtracting and taking the absolute value of those two numbers. Right, so 1 minus a -3 would come out to be 4, right? The absolute value of 4, and the absolute value of 4 is 4. Or you could do it down here as well. If you could do it with -7 minus -3. So you know the midline is at 3, -3. The minimums are at -7. So just subtract those two in any order. It doesn't really matter. And take the absolute value. You're going to get the amplitude as well. Okay. So that's how you would find it if you just had the graph. All right, next one. Find the amplitude of the sinusoidal function. All right, and so let me turn this one on. So from the formula, it's really straightforward. We look at the value for A. In this case, it's 3, and take the absolute value. Absolute value of 3 is 3. So that's the amplitude. It's, again, pretty easy from the formula. From the graphs, now suppose they didn't give us this and we just want to find it from the graph. Again, find the midline first. So the maximum values are 5, the minimum values are -1. So it would be 5 plus -1 divided by 2, right? That would give us the midline right here. So that's the line halfway between the minimum values and the maximum values. And then find the distance, right, from the midline out up to one of the maximum values, the straight line distance. So what's the distance between 5 and 2? Well, that would be 3, right? And again, you can always do that by taking the absolute value of the y coordinates of the maximum value, 5, and subtracting the where the midline is, the vertical shift, right? You can also do that with the minimum values as well. So if I did absolute value of 2 minus -1, right, where that's the y coordinate that's on the of the points on the midline, and subtract the y coordinate of the minimum values and take the absolute value, you're going to get the amplitude as well. Okay, and that is it for this one.